The following video is a compilation of the design process SolVaCov has been developing in the last month for the second sprint. This stage focused on the refinement of the needs of the target audience, the prototype, and the harmonization and definition of requirements. In the first sprint, two target audiences were analyzed. In one hand is the municipality of Nueva Granada, Magdalena, with a population of approximately 16,000 people. It's characterized by its scorching temperatures around 35 degrees Celsius and issues related to the stability of power sources. On the other hand, there's the municipality of Arboledas in Norte de Santander. This region has a limited number of third-level routes, which increases the risk of a breach in the cold chain in case of isolation due to landslides blocking the road. Therefore, a couple of needs were considered in relation to both audiences. First and foremost, the vials must be stored at temperatures ranging between 2 degrees Celsius and 8 degrees Celsius, whilst exposed to an average temperature of 35 degrees Celsius and peaks up to 40 degrees Celsius for 12 hours without external power source. Secondly, the system must be light and portable so the container can be transported by foot without a chance of causing the user health problems. However, a third need was introduced during the last stage, which is the monitoring of the temperature of the vials to inform any irregularities during the journey. Now, for the refinement of the requirements, a harmonization committee consisting of representatives of each company was created. The group shared their restrictions and criteria according to their needs. After discussing different points of view, the group defined an ultimate list of overall requirements, ordered by a global score. SolVaCov adopts several requirements from the list and applies it to the quality function deployment matrix. Furthermore, the set of restrictions was refined, such as the range of admissible weight, refrigeration temperature, storage capacity, power consumption, and thermal conductivity of the insulating material. The list of criteria was refined as well. To name a few: autonomy, internal distribution, cost, weight, total volume, and thermal insulation. At the same time, SolVaCov has been polishing the concept of solution. In the first sprint, a handful of concepts were evaluated. The compression refrigeration system turned out to be impractical and heavy. The concept involving PCM packs seemed like a great candidate for the solution and future embodiment. However, it was once again a hefty and much more expensive solution. Consequently, SolVaCov concluded that the system involving Peltier cells was the way to go. The latter went through a process of evaluation elaborated back in the first sprint. From those results, two prototypes emerged. The first one has a capacity of 1,000 doses, 30 centimeters on each side, a total weight of 25 kilograms, polypropylene walls filled with polyurethane, and the 0.0125 cubic meters of capacity. Now the second alternative stores the same number of vials, weighs 20.5 kilograms, has dimensions of 26 by 26 by 28 centimeters, a PVC casing filled with polyurethane, and the property of stackability. At the end of the sprint, these were the results. The system divides into two subsystems: the control and circuit subsystem and the structural and design subsystem. The solution includes a LiPo battery, a temperature controller with a 12-volt DC input, among other characteristics shown right now. The team is looking for a way to embody the concept without relying on a LiPo battery for the next stage, since it may end up costing around half of the budget. Also, the team already started purchasing the fundamental elements for the embodiment. SolVaCov expects the third stage will show the unseen flaws digital models possess. Thank you for watching.